All right, I'm glad that you're showing up. I don't know what happened there. There was about 10 minutes with me not getting any notification of anybody, and then all of a sudden 20 people in just a matter of 2 or 3 minutes. So not sure what was up. Sorry for any inconvenience on your part. I also need to mention to you that apparently Zoom had some issues over the last couple of weeks with all of the, especially schools, but families and everybody else doing Zoom meetings with random people just joining meetings and then causing problems and putting up pornography and whatever else. So Zoom has added this password function, and you knew about the password because you logged in. Zoom has also added a waiting room. So instead of coming straight to the meeting, you go to this waiting room, and then I have to admit people one by one or two by two, or however many people are in the waiting room. I have to admit every time somebody else shows up. So it would be helpful if you were as prompt as possible. Also, Kool-Aid is not a real name. I need your real names so that when I see you, I know who you are, and don't have to worry about if it's some random freak getting ready to put pornography up. So today I'm going to do one more sample problem, and then tomorrow I will start giving you problems to do for a grade. I have still not been able to figure out where your work for those pH problems went. So in the future, PFGs will be something that you have to take a picture of your work and turn it in. You'll be saving it to the Google Drive folder that I sent you a link to. Also, please make sure that you put your real name on it, and you will need to log in with your GCS email, because only people with GCS email addresses have access to that folder. So please keep those things in mind. Other than that, seems like there was one more thing. After today, for this week, I'm only talking this week. So Tuesday, Wednesday, Thursday, Friday is a Good Friday. We won't be doing that. Okay, so please try and stay here if you can, so I don't have to readmit you. So after today, Tuesday, Wednesday, Thursday of this week, the live streams will be help sessions. If you can do the PFG, you'll need to log on, I suppose, long enough to get the PFG. If you can do the PFG on your own, you don't have to stay in the session. If you want to log in, get the PFG, log out, log back in if you have questions, that would be fine. We'll probably have to practice at how exactly I can look at your work to see what your issue is and help you with it, but we'll play around and we'll get something figured out. But again, it's optional only if you need help. I will record those, I suppose, but keep in mind that if you're going to be asking questions, you have to be in the live stream, the recording. You can't ask questions. All right, so here we have an equation. Right. My console is hiding the pen. No, it isn't. Why won't you give me a pen? There it is. All right, so we're going to be doing this problem that you see at the top of the screen, iron plus Cr2O7. And if you have questions along the way, feel free to raise your hand and ask about anything we did. I know it's been a week since last time. That's why we're doing this review. And we're just going to go down this list of steps in our little box in the upper right-hand corner. So we start with determine what's oxidized and what's reduced using oxidation numbers. So the rule Fe plus 2 or 2 plus, the 2 plus makes this an ion. Ions are the same as their charge, so this is plus 2. Cr2O7 is a compound. Now this may remind you of a polyatomic ion, but there's no charge in the corner, so it's a compound. Unless there's a mistake in the problem, then we're just going to be out of luck. So oxygen is -2, and there are 7 of them. So that means that if there are 2 chromiums, it must be +7. So that +7 times 2 is +14. -2 times 7 is -14. So that adds up to 0. On the right, ions are the same as their charge. And so iron is +3 and chromium is +3 because it's the same as its charge. So what goes up, what goes down? Oxidized, let's see, oxidized is up. 2 plus 2, 2 plus 3 is an increase. So iron is oxidized. And then chromium goes from +7 to +3. That's a decrease, which is reduced. So chromium is reduced. So we have determined what's oxidized and what's reduced. Step B, write the half reaction for each of the elements. So we'll have 2 half reactions, 2 halves make a whole. And remember on this, you should have written down in your notes that we need to write symbol, subscript, and oxidation number for each. So symbol is iron, Fe, on the left. And the subscript is an understood 1, and the oxidation number is +2 or 2 plus, either way. Still sticking with iron on the right, it's +3. So get my pen back here. Iron, no subscript, oxidation number of +3. That's all for the half reaction. Now for the second half reaction, chromium for reduced, subscript, symbol, Cr, subscript is 2, and its oxidation number is +7. And then our arrow in the right side, this is simple. Symbol is Cr. Subscript is an understood 1. And the oxidation number is +3. So now we've got our half reactions. Now remember, keep this straight. Balance, balance, balance. Doing different things each time. So balance the elements using coefficients. And remember, we're doing these one at a time. Don't do that. You can't erase it all at once like I can on the computer. So how many irons on the left? Understood 1. Irons on the right? Understood 1. So that's already balanced. Now we'll do the second half reaction. Again, if you don't understand something, click the raise your hand button and we'll answer your question. So CR's on the left, 2, because of that subscript right there. CR's on the right, only 1 because of that subscript. So we'll need a coefficient of 2 in front on the right so that we've got 2 CRs on the right and 2 CRs on the left. So now we are done with this part. And we can get this back now. And now the next step, again, we've got all these balances. So step D, balance the charges by adding electrons. If you remember, hopefully you have written down in your notes by this step, it is coefficient times subscript times oxidation number. So understood 1 in front of the first Fe times understood 1 times plus 2 makes plus 2 on the left side. On the right, 1 times 1 times 3 makes plus 3 on the right. Plus 2 on the left. Hope I said that right. Plus 3 on the right. Now those don't equal each other. So we're adding electrons, which is subtracting. 2 plus 3 minus 1 would make that equal. So this minus 1 on the right becomes plus 1 E negative. And I could leave leave this coefficient out. It's understood. And now I am done with this. That was just a tool. Now the second half reaction. Now we'll do this one. So 1 times 2 times 7 is 14 on the left, and 2 times 1 times 3 is plus 6 on the right. Obviously, they don't match, so it would have to be, remember, we're subtracting down the high side on this step, so that's minus 8. Minus 8 plus 14 is plus 6. So that minus 8 becomes, oops, got to get that out of my way. That minus 8 right here becomes plus 8 electrons. Remember, electrons are negative. So now we're done with this step. It was just a tool. We've got step D finished. And we're ready to go to step E. If you're not following anything, again, click the raise your hand button and we'll get your question answered. So again, E is balance. Now we're balancing the electrons between the half reactions using the least common multiple. So the least common multiple of 1 electron in the first half reaction and 8 electrons in the second half reaction. Least common multiple of 1 and 8 is 8. So we'll have to multiply through every coefficient in this reaction by 8. So understood 1 times 8 is 8. Understood 1 times 8 is 8. And 1 times 8 is 8. Let's see if I can squeeze that in there. We already have 8 electrons in the second half reaction. Technically, I guess you could say we're multiplying through by 1, but multiplying through by 1 doesn't change anything. So we're good to go. Done with E. Step F, if you have no questions, cancel the electrons and add the 2 half reactions. So cancel, cancel. Then we'll put our arrow from the left side, 8 Fe plus 2 plus CR2, CR naught, plus 7. And then on the right, 8 FE plus 3. And 2 CR plus 3. All right, so done with F. Now we're at the if then. So we have to check. Is there any elements in the original equation which were not in step F? This is step F. This is step F right here. So is there anything there that was not in the original equation? I'm going to erase my work. Remember, all of this stuff, whatever I wrote, was not the original equation. Only what was there typed out to start with is the original equation. So is there anything in this equation that is not in step F, which is down here? And the answer is absolutely. We have oxygen there that's not right here. So we have to continue on. So we've checked that. So now we rewrite the original equation. Remember it, remember. I cannot stress this enough. Only what was there to start with is the original equation. The stuff I wrote in figuring out oxidation numbers is not the original equation. So rewrite the original equation. I'll spread it way out so I have room to work. Fe2 plus CR2O7 arrow Fe3 plus CR3 plus. Now I drop my coefficients down. The 8 goes with wherever Fe came from on the left, which is right there. Understood 1, where in front of wherever the CR2 is, which is right there. So that'll stay in understood 1. On the right, 8 in front of wherever the Fe came from, and 2 in front of wherever the CR came from. So give myself a little more room here. And then put it back where it's supposed to be. All right, let's see. We rewrote the original equation. So balance any non-redox elements by inspection. This step, remember, this step frequently is skipped. The problem with that is when it's done, people tend to forget to look for it. So is there anything other than the iron and chromium or oxygen or hydrogen? Nope, we skipped this step again. Step I, balance any other charges by adding hydrogen. If you remember, if you don't have it written down for step I, you should write down it is coefficient times oxidation number. So on the right, left, we've got coefficient of 8 times an oxidation number of 2 is plus 16, 2 times 8. Right here, subscript, no, coefficient times oxidation number. So 1 times 0 is 0. So the left side adds up to plus 16. On the right side, 8 times 3 is 24. And then 2 times 3, that's coefficient times oxidation number, is 6, for a total of 30. Now, 16 does not equal 30. This time we are not subtracting, this time we are adding. So we have to add what? What plus 16 is 30? That would be plus 14. 14 plus 16 is 30. So this plus 14 becomes 14H plus. On the same side. This was on the left, we needed the plus 14, so the plus 14H plus goes on the left, the reactant side. Done with that. Now we balance the hydrogen and oxygen by adding water. Now, we either balance the hydrogen and check the oxygen, or we balance the oxygen and check the hydrogen. Works either way. So how many H2s does it take to get 14 H's? H2O 7. H2Os would be 2 times 7 is 14 H's. Now, if our oxygens match, we know we did it right. So let's check that. So we have no oxygen, no oxygen. There's 7 oxygens. On the left, the oxygens are 7. On the right, no oxygen, no oxygen. 7 times 1 is 7 oxygens. So the fact that these two numbers balance means that our completed equation is almost certainly right. And that would be the final full credit answer. Now, I'm absolutely certain, based on a bazillion years of doing this, that many of you are like, yeah, I got everything as you did it. And then when you have to do on your own, it's all of a sudden, huh? I don't remember how to do that. So I understand that. And that's why we'll be here to help you when you have to do the problems on your own. I think that we will be able to use the camera on your whatever device you're using to take a picture of your work so that I can see what you're doing and help you with it. But maybe something else will work. We'll try it and figure out. So as far as that goes, that's all I have for you today. Tomorrow there will be a quiz for you to take online, and there will be a PFG. You will need to log in and get it, and then to the Zoom meeting, log into the Zoom meeting, copy down the PFG, and do the best you can with it, and then ask questions as you have them. As always, you will be able to work on it until the class session, quote unquote, the Zoom session is done for full, and redo it for full credit. After that, you're on your own, but you are still not allowed to get other people's work and copy it down. It would be more difficult, but I'm sure you're to do that, being all in different houses, but I'm sure you have enough ideas of how to use your technology that you could still make it happen. All right. Yes, Sydney.
Do you have a PhD today?
All right, you're gonna have to say that again. It did not come through.
Is there a PFG today?
Nope, we'll start those tomorrow. Any other questions? Avery?
So there's no quiz at all today.
I don't think I said anything about a quiz, but
All right.
I can double check and make sure didn't forget something here. Quiz online on Wednesday and Thursday. So no quiz today, no quiz tomorrow. Quizzes will be Wednesday and Thursday.
I bet.
All right. Any other questions? Avery? No, or is that an old one? Well, if there's nothing else, I guess we're done then. So log on tomorrow, try and be as close to 9 o'clock as possible so you have all of the time to work. And you have a good day otherwise. Jonah?
Will it be open out like usual?
Yes, it'll be like usual.
Okay.